Good day. With your permission, I present a work, Modified Neural Network Fault-Tolerant Closed Onboard Helicopters Turboshaft Engines Automatic Control System. It is known that the assessment of helicopters' turboshaft engines' operational status in the condition of their flight operation is carried out, as a rule, according to a limited amount of information due to the small number of standard controller parameters. This significantly limits of effectiveness of parametric methods based on the identification of mathematical models of engine workflows. Therefore, it is relevant to conduct research to improve the efficiency of onboard method for helicopters' turboshaft engine operational status monitoring, including the method of neural networks. The analysis of modern literature devoted to neural network and neural network control systems shows that despite the ongoing active developments in this area, many issues related to the development of algorithm and method for identification nonlinear objects based on neural network models, synthesis of the structure and adaptation, training algorithm for the parameters of neural network controller, features of their implementation in multi-mode control systems for nonlinear dynamic objects. All of the above fully applies to such a dynamically complex class of control objects as helicopter's turboshaft engine. The helicopter's turboshaft engine closed on-board automatic control system was developed by this author's group and is shown in figure. As an effective way to ensure fault tolerance, you can use the so-called active approach based on the reconfiguration of the neural network controller using a selector in case of emergency situation in the operation of the automatic control system. Bottom figure shows a diagram of a closed-loop helicopter's turboshaft engine automatic control system in which a supervisory neural network is used to tune the parameters of a linear pit controller depending on the engine operational status and external conditions. Compared of the classical tabular methods of approximating the coefficients, the neural network approximator provides more flexible adaptation training to changing external conditions and turboshaft engine parameters. Thus, the modified closed onboard helicopter's turboshaft engine automatic control system is present on this slide. For the purpose of signal or parametric adaptation, the developed automatic control system is supplemented with connect adaptation modules that implement adaptive control methods. Signal adaptation module, parametric adaptation module, linear model submodule, customizable model submodule. To solve this task, the methods developed by Professor Volodymyr Vasilyev were applied. A multilayer neural network of the perceptron architecture with 3 neurons in the hidden layer and 1 neuron in the output layer is taken as a neural network controller. The total numbers of weight of synaptic connection, configuratable parameters of the neural network controller. 9. Type of neurons activation function, tangential sigmoid. At the same time, it is proposed to use a variable training rate parameter for each layer of the neural network as a function of the error of neurons on the corresponding layer. The input data for training the neural network are the following parameters of helicopter turboshaft engine, which are recorded on board the helicopter. From the one shown in this figure of the transient process, it follows that automatic control system with a neural network controller provides the best quality of control. The dynamic control coefficient is 6 times less. The control time is 2 times less compared to a system based on a PID controller with constant settings. This figure shows gas generator rotor r.p.m. signal timing diagram with continuous disturbances and the operation of gas generator rotor r.p.m. Automatic control system with and without neural network adaptation. The results of comparative analysis are present in this slide. The conducted experimental research has shown the feasibility of using a multi-stage neural network controller in modified closed onboard helicopter turboshaft engines automatic control system. The conclusions are presented on this slide. Thank you for attention.